Hello. So in this video, we're going to be talking about line or lines of symmetry. Now, the line of symmetry, it's a line that divides a shape into two identical halves, and then these identical halves match when you fold them, and that's very important. Okay, the folding part. Okay, so the line is going to divide. So let me give an example. Have a circle here. Then we can draw a line that goes. Okay, so we have a circle here. And we can decide to draw a line that goes through the center of the circle. Okay, sorry. And divides the circle into, even if it's not straight, but okay, I think it's better. All right, so we have this line here that divides the circle into two equal halves. All right, so one and two. And then when you fold it together, when you fold them together, you have something like a semicircle. Okay, sorry, this is what this. Okay, so when you fold them together, you have something like a semicircle like this. All right, so you can see both sides or both halves actually match. And the thing is that this line of symmetry generally passes through the center of the shape, or in this case, the center of the circle. If we were to draw another line, let's say, let me say, if I was to draw another line somewhere around here, okay, and decide to draw a line somewhere around here. Okay, it divides the circle into two parts that are not identical at all. And then when you try to fold these two parts, you get something like this. The larger part, something like this, and then the smaller part is, kind of there. So these are not identical, so not they don't match. So not matching. Okay, so it means that this line is not a line of symmetry. Okay, you can also have that for the square. You can do that for the square. We can draw a line that divides the square into two equal halves. So something like this. Okay, you can see this line divides the square into two equal halves, and then when we fold these two halves together, we get something like this. Sorry about my drawing, but you get the idea. So you can practice this with like a square paper, some circular papers, and see the difference. Okay, try to fold, say, the circle across at the center, you get two equal halves. If you try to fold maybe somewhere, that's not the center, you get something like this. Now let's talk about, the number of lines of symmetry. Okay, the number of lines. So number of lines of symmetry for different shapes. So for a circle, now the interesting thing about a circle is that, so I'm just going to erase this. So as long as you draw a line, like as long as you have a line across the center of the circle, that line can divide the circle into two equal halves. So we have something like this. Okay, so sorry. Okay, okay. Let's say we have this line here. You can see it divides the circle into two equal halves. All right, we can decide to draw another line. Let's say from here. You can see it also divides the circle into two equal halves. Okay, we can do it horizontally, vertically. Okay, so sorry. Draw another line across, across here. It can even be like this. See, it divides the circle into two equal halves as long as it passes through the center. So for a circle, you can say a circle has an infinite amount. So it has an infinite amount of lines of symmetry. Okay, because you can have so many lines, right? And now for a square has four sides. We already made one line. Okay, number one. We can also draw a line horizontally. Okay, also draw a line horizontally that divides the square like this into two equal halves. Okay, so when we fold this, we get something like this. So equal parts. Okay, and then we can also have a line that goes diagonally, say from here to here. Okay, we can also have this line that goes through the square diagonally. I'm gonna move these arrows. Okay, all right. I think this is okay. So we have this line that goes through the square diagonally, and when we try to fold these two together, we fold them like this. It's gonna give us something like a triangle. Okay, and then we also have one that goes. I'm just gonna draw it with my number. That goes like this. So generally, a square has four lines of a symmetry. Okay, so a circle, infinite amount of lines. A square, four lines. So I made a table. Okay, so the table here you can see for a circle, infinite, square, four. Okay, for a rectangle actually has two lines of symmetry for an isosceles triangle and all these parallelogram, rhombus, kite. Let's just look at the rectangle. Now, the rectangle has two lines of symmetry. But one would expect, okay, it's four-sided like a square, but why doesn't it have four like the square? So let's try to look at that. Okay, so look at our rectangle. We want to draw lines of symmetry. Okay, we can draw the first one vertically. Should be at the center somewhere. Okay, somewhere around here is fine. Okay, as you can see, it divides the rectangle into two equal halves. So this is a line of symmetry. When we fold them together, it's gonna give us something like this. No, correct, it's fine. Then we can also have it horizontally. We can draw a line horizontally. Something like this is fine. Okay, and then it divides the rectangle into two equal halves. If we fold it like this, we also have a rectangle, something like this. Okay, so you can see we had one and two. So let's try diagonally and see what happens. So we draw a line here, here, okay. And then we try to fold this. So let me quickly erase all this first, so it's just not a distraction. Now we try to fold these parts and see what happens. If we try to fold this, we get something like this. Now, this long part tries to come here. It's kind of it's messy and all that, so it doesn't work. Actually, it doesn't work, and that's why this diagonal line here is not a line of symmetry for a rectangle. So you can actually try it. Maybe try it with a rectangular notebook and try to, do it diagonally and see what happens. You cannot, okay, you can't get equal halves. It's not possible. Okay, so for this reason, a rectangle only has two lines of symmetry. Yes, this diagonal line was going to divide the rectangle into two similar triangles, but you can't fold them together. That's the thing. So that's just the idea of lines of symmetry. For an isosceles triangle, you just have one line in the middle. Sorry about my line. I have to move it to the middle. Okay, somewhere around here is fine. I think this is okay as long as it passes through the middle. It's not perfect, but yeah, I think this is okay. Okay. If we try to draw, let's say, a line across here, if we try to draw a line across, maybe say here, the two sides are not identical. Let's say horizontally, they're not identical. If we try to draw a line like this, maybe like this. Oh, sorry about my lines. Okay, so the two sides are not going to be identical. It's only one line that actually, um, okay, if we try to draw this, we're going to have something like this. I have one part like this, then another part that's, has bigger length, and you can fold this together. It's not going to work. So that's just the idea for lines of symmetry. Okay. Now, actually, when it comes to symmetry, this one is what we call reflectional. So reflectional symmetry. Reflectional symmetry. So that's what we're talking about right now. Okay, there's also rotational symmetry, which is what I'm going to talk about in the next lesson. I'm going to make a video about rotational symmetry. And there's also what do you call transfer? Some people call it translational, or transformation symmetry. I think transformation symmetry is the general name. It's transformation symmetry. So we've talked about reflectional symmetry, but there's also rotational and then transformation symmetry. So I'll talk about it in the next video. So if you enjoyed the video, please leave a comment and I'll answer your questions. So thank you and have a nice day.